Hey everybody, today we are taking a look at lesson 4.5. We're looking at ratios in right triangles. Our learning targets are going to be to use a table that we made last week in class. That was the one with the ratios of the side lengths of right triangles. We're going to estimate unknown angle measures, and we're also going to estimate unknown side lengths. First, we need to start off by remembering what does that Pythagorean theorem say? If we have a right triangle where A and B are legs and C is the hypotenuse, then we know, and you guys can write this in there. I'm just going to add it in. We know that A squared plus B squared equals C squared, or the two legs, the lengths of the two legs squared equals the hypotenuse squared. Okay, so with the Pythagorean theorem, if we have a right triangle where A and B are legs and C is the hypotenuse, we know then A squared plus B squared equals C squared. But now we're being asked to take a look at the converse. And a converse is a statement that switches the arguments in a conjecture. So our conjecture was the Pythagorean theorem: if we have a right triangle where the legs and so on and so forth, then A squared plus B squared equals C squared. So with the converse, we're going to switch. Instead of saying if this, then that, we're going to say if that, then this. So the converse of the Pythagorean theorem would be if A squared plus B squared equals C squared, and we're just going to copy this from here and paste it over here. So we say if A squared plus B squared equals C squared, then we have a right triangle with legs A and B and hypotenuse C. Okay, and the notation is using our caret to indicate that those are squared, so that's just fine. Okay, so next we want to say, hey, if we have a triangle that has side length 7, 24, and 25, is that a right triangle? How would we find out? Well, we use the converse in this case and pull down your calculator. We say, well, if these were the side lengths of a right triangle, then we know that 25 has to be the hypotenuse. So it would be 7 and 24 would be the legs. So it would be 7 squared plus 24 squared. Whoops. Put a 2 in front of there, 24 squared, and we see that that equals 625. But that's supposed to be 25 squared. And if you don't know that 625 is 25 squared, then please hit the enter, and you can still see the problem, 7 squared plus 24 squared. And then now let's type in 25 squared, and you'll see on the right that yes, indeed, that is equal. So yes, that is a right triangle, the measurements for a right triangle. And then you can explain your thinking using the numbers that we have on the right-hand side. Okay, so we want to sketch the triangle with side lengths 7, 24, and 25 units. So the 7 is going to be the short side. 24 is going to be the side that's adjacent next to that, and then our hypotenuse is opposite the right angle. And then we're asked to label the smallest angle A, the 90-degree angle C, and the third angle B. So our smallest angle is going to be opposite the smallest side. So this is our side that's 7. This one is 24. and our hypotenuse is 25. Remember, 7 and 24 were the legs. This is going to be A. Here is going to be not C, nope, tricked you there. And we're going to do C over here at the right angle. Again, just a reminder that the smallest angle is going to be opposite the shortest side. And then our largest angle, the right angle, is going to be opposite the longest side. So when you're done drawing, click the done drawing section, and then they're asking you to type in the lengths here. So find the three ratios, and for the adjacent leg, you should have 24 over 25. For the opposite over hypotenuse, we should have 7 over 25. And then opposite over adjacent, we're going to have 7 over, whoops, I put in 72. Sorry about that, guys. 7 over 24. Okay, and then submit that if you will. And let's move on to the next page. All right, now we're going to use this information. Remember, we wanted to use the information. Our goal for the day is to use that chart and the information we know about a right triangle to estimate the angle measures. And so we're going to estimate the measure of angle A by looking at that ratio that we have, 24 over 25. And you can go ahead and plug that in. What is 24 over 25 as a decimal? Because that really is what is going to help us find the angle measure in our chart. So we have 0.96, and we look in the chart. It's listed there on the page for you. What column are we going to look in? Well, we're looking at A, and the measure of angle A we had was adjacent over hypotenuse, and that was 24 over 25. So we need to look in the first column, and we have 0.96, which falls between 10 degrees and 20 degrees. So we can estimate, well, 0.98, 0.94, it's about halfway. So we can say, hey, this angle is about 15 degrees. So, and we're just estimating here. So you don't have to be exact. But I'm going to guess you're really close. So that one's 15 degrees. And then we find the measure of angle B, and you can look at the measurements if you want, or just realize, remember, what is the sum of the measures of the angles of a triangle? Yes, I hear you all, 180 degrees. So that means at angle B, since C is 90, now we know measure of angle A is about 15. That means that B has to be 75 degrees. Okay, and again, submitting our answers and moving on to page 7. What is the length of segment AB? Now, we're going to solve 2 more triangles here and look at the segments this time. And to do that, we might first want to highlight the segment that we're trying to solve for. So in this case, I'm looking for segment AB. So I'm going to highlight that one, whoops, really well for us and say, there it is. That's the one I'm looking for. So I have a 20-degree angle. I have the hypotenuse, and I'm trying to find AB, which is the adjacent. So what I'm going to look at is, these are the things I have. I have a 20-degree angle, and I have the hypotenuse and adjacent. So I'm going to use the adjacent over hypotenuse. That's what I'm going to look on in that chart, and I'm going to look for this 20-degree angle. Okay, so over here on the 20-degree angle, I notice adjacent over hypotenuse. Here I am, adjacent leg over the hypotenuse, and I see, hey, 20 degrees, well, that's 0.940. But how the heck is that going to help me here? Well, what I need to do is set up an equation, and I know that the adjacent over hypotenuse is going to equal 0.940. So let's erase some of these things. And so I know that this adjacent over hypotenuse, whatever that's going to be, it has to be, according to my chart, 0.940. Okay. I also know that I have a measure here for the hypotenuse. So I can come in, hey, I have that hypotenuse. I know that measure. So let me put that in. It's going to be 8.5. So the adjacent side is the one I'm looking for. I'm going to call that X. And guess what? When I erase the adjacent above, I have what looks like an algebraic expression. Indeed it is. And now I can solve that. So X is going to equal 8.5 times 0.940. So using my calculator, 8.5 times 0.940, it's 7.99, or about 8. We would round that and say, oh, that's about 8. And so that's what I would tell you to submit it as, about 8 degrees, or excuse me, 8 units. Okay, next one. We have a right triangle with one angle measuring 70 degrees, and the leg opposite the 70-degree angle is 12 centimeters. So what's the leg of the length of the leg adjacent to the 70-degree angle? Here we're going to have to draw this right triangle, and when we do that, we want to get an angle that's about 70 degrees. And again, it doesn't matter. My sketch is probably not perfect. I probably do not have a 70-degree angle here, but the point is nonetheless to put in the numbers that we do have and say, oh, I'm going to call this one my 70-degree angle. I know that the leg opposite that 70-degree angle is 12. And I know that I'm going to try to find the length of the adjacent leg. So that would be this leg right here in red, and I'm going to call that one X. Okay, so I look on my chart. Now I have opposite over adjacent. So that's our third column over here. I look at the 70-degree angle, and I see, hey, that's 2.747. And so that's the number I'm going to use. I'm going to set my ratio up equal to, and the ratio again is opposite. Opposite is 12 over the adjacent, which is X, and that is going to equal 2.747. Okay, now with this one, I'm going to go through and have to do a little more work with it for you. So again, this is my decimal there. We need to multiply both sides times X to get the X out of the denominator. So that's going to give us 12 equals 2.747 times X. And then to solve for X, we divide both sides by the 2.747. Remembering our algebra here. And that is a decimal right there, guys. So we use our math tools again, and 12 divided by 2.747 is telling us that that segment is about 4.36 units. So this time I don't think I'll round it. I'll just leave it as 4.63. And you talk to your teacher and see what they want you to do to make sure that you're giving the correct answer. So. Okay. Alrighty then, submitting it and moving on. So last thing for you to consider today is there's some questions that I want you to think about. You're going to answer these. They're going to be given to you again in class. Why does having the right triangle table give you enough information to find unknown lengths and angle measures in a right triangle with only two other measurements given? What are you good at using the right triangle table to figure out? And what is the hardest thing for you about using that right triangle table right now? I'd like you to choose one of those questions and be ready to answer it in class when I see you or when your teacher sees you. Then finally, here's some information that you can put in your notebook. In fact, I urge you to get it in your notebook. This information that will be helpful for you about right triangles, and we'll be talking about it in class.